Hello, welcome to STEM School. In this lesson, we are going to go through Math Gauss Contest selected problems.
So question 11, in the diagram, triangle on BCD is a straight line segment. So the measurement of angle ABC is, okay, so for this diagram, we have a triangle ABC, right? And we know the value of the angle BAC is 35 degrees. And as we can see, ACD is the exterior angle of the triangle ABC. So we can use the exterior angle theorem, which is the value of the exterior angle ACD will equals to the sum of the two angles not next to it, which is BAC plus angle ABC. So we know ACD is 75 degrees, and we also know BAC is 35 degrees. All we need to find is angle ABC. So angle ABC, by solving this equation, which is 40 degrees. So the answer is B. Number 12, square WXYZ is divided into 100 small identical squares. Some small squares are shaded and some are unshaded as shown. How many more of the small squares need to be shaded so that 75% of the area of WXYZ is shaded? Okay, so let's see how many squares are shaded is the first thing we need to find. Okay, so actually as we can see, so this big 100 small squares has been divided into 4 equal squares. So 4 equal squares, which means each of them has 25 small squares. So this is 25, this is 25. So in this case, at least we have 50 shaded. And for this part, each of the square are shaded. So in this case, we will have, we can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 shaded, and for this part we have 1, 2, 3, 4, 5, 10 shaded. So we can add all of them together. In total, for the shaded part, we have 72. Okay, so we want the small squares need to be shaded so that 75% area is shaded. So we only left 75 minus 72, which is 3. We need 3 more shaded squares. Answer is A. So number 13, in the diagram, the points 2, 1, 4, 1, and 2, 5 are 3 vertices of a rectangle. Okay, so what are the coordinates of the 4th vertex of the triangle? Okay, so let's see. We can connect the 2, 5 and 2, 1. We can see the side length, the length will be 5 minus 1, which is 4. So this one should be in here. And the y vertex will be 1 plus 4, which is 5. And for the width, it's 4 minus 2, which is 2. Same thing for 2 plus 2, which is 4 for x-axis. So the vertex, which will be D, 4, 5. Number 14, the sum of two different prime number is 10. Two different prime number is 10. So the product of these two number is, okay, so we can list all the prime numbers smaller than 10. In this case, we can find it, okay? So the prime numbers should be start from 2, 3, 5, and 7, right? So which two number add together will give us 10? 3 and 7, okay? So 3 and 7, 3 plus 7 is 10, and the product is 3 times 7, which is 21. Number 15. Suppose n is a number such that the mean average of the list of the number is 2, 9, 4, n to n is equal to 6. What is the value of n? Add them together and divide. So the average is the sum of the numbers divided by the number of the numbers. So in this case, which is 2 plus 9 plus 4 plus n plus 2n. Divide by the number of the numbers. How many numbers in total? 1, 2, 3, 4, 5, 5. And the average is 6. So all we need to do is to solve this equation. So it's 6 equals to 15 plus 3n over 5. So we times 5 on both sides, which will give us 30 equals to 15 plus 3n. So 15 is equals to 3n, so n is 5. Value of the n is 5. D. Number 16. Each number from 1 to 6 replaces one of the letter P, Q, R, S, T, and U. The sum of the P and Q is 5. Okay. So P plus Q is 5. And the difference between R and S is 5. So R and S minus R is also 5. If T is greater than U, what number replaces the letter T? Okay. So the number is 1 to 6, right? So the S and R must be 6 and 1. 6 because 6 minus 1 is 5. And the P and Q, add them together is 5. It can be 2 and 3, 1 and 4. So we can't decide which number is it. 2 and 3, which combination? 1 and 4, right? So T is greater than Q. Since R is 1, so P and Q can't be 1, right? So only 2 and 3 can be P and Q. And we have already used 1, 2, 3, we left 4 and 5, right? So T is greater than U, which is 5 can be greater than 4. So T is 5. Answer is E. Number 17. In the diagram ABC, triangle ABC is a right-angled isosceles triangle. Right-angled 90-degree isosceles AB equals to CB. D is the midpoint of BC, and E is the midpoint of AB. AB equals to BC equals to 24 centimeter. What is the area of triangle AED? Okay. So for this one, AE, we can treat the AE as a baseline. So it's half of AB, which is 12. Okay, and the height, we can use BD. BD is also 12, right? Because if we extended line AE, and it will connect on the point B. It's also the height of the triangle AED. So in this case, we can write it AE times BD divided by 2, which is 12 times 12 divided by 2. So 72 centimeters squared. Answer is C. Okay. So next, close the rectangle prism. 18. Close the rectangle prism with height 8 is standing on a face with dimensions 2 cm by 5 cm. The prism contains water with a depth of 6 cm as shown. When the prism is tipped so that it stands on a face with the greatest area, the depth of the water is. So the water in the shape of the rectangle prism with a 2 cm by 5 cm base and a depth 6 cm. So therefore the volume of the water should be 2 times 5 times 6, which is 60 centimeter cubed. And the face of the prism having the greatest area has a dimension 5 by 8. So it's 5 by 8, which it should be 5 times 8 times the height times the depth, right? Equals to 60. So we can calculate it. The depth should be 60 over 40, 3 over 2, which is 1.5 centimeter. Answer is D. Okay. So number 19, 2 standard dice are rolled. The product of the two numbers rolled is calculated. What is the probability that the one digit of this product is 0? What is the probability that the ones digit of this product is 0? Okay, so in this case, we need to list all the probabilities which will all their products which will give us their product is 0. This is more clear. Okay, so 1, 2, 3, 4. 5, 6, and 1, 2, 3, 4, 5, 6. Okay, so let's see their last digit. Let's use another color. So 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 1 times 6 is 6. Last digit. Okay, we will only focus on the last digit, the one digit, right? So 2, 1, 2, 4, 6, 8. Okay, our first 0 is here, and 2. Next, 3, 6, 9, 2, 5, 8. 4, 8, 2, 6. Okay, our next 0 is coming. So 4, 6, 4. 5, 5 times 2, 10, right? Another 0. So 15, another 0 again, 20. 25, another 30, another 0 again. 6, 2, 8, 4, 30, which is another 0, give us, so 6. So how many 0 do we have? 1, 2, 3, 4, 5, 6. So 6. 6 divided by 36. Simplified it, 1 over 6. Answer is D. 20. How many pairs of positive integers a and b satisfy the equation a over 7 plus b over 2 over b is 1? Okay, so this one, we also need to list all the possibilities. Let me find the space in here. So their sum is 1 and they must be greater than 1. Okay. So in this case, each of them should be less than 1. A over 7 is greater than 0, less than 1. Then the positive value of A will be make some space. So 0 is smaller than A over 7, smaller than 1. So the value of the A can be 1, 2, 3, 4, 5, and 6, right? So if A is 1, which will be 1 over 7 plus 2 over b equals to 1. We can solve it, which, let's see, no, b is not a whole number, right? In this case, b is 14 over 6, which is 7 over 3. So no. Next, let's see if A equals to 2 is workable. So 2 over 7 plus 2 over b equals to 1. So for this case, b is 14 over 5. Also no. 3 over 7 plus 2 over b is 1. So for this case, 7 over 2. Also not a positive. So we try, let's erase 4 over 7 plus 2 over b. So for this case, b equals to 14 over 3. No. Also a no. Okay. So we have tried 1, 2, 4. All of them are not workable. Then let's try the rest. Okay. So 5 over 7 plus b 2 over b is 1. So for this case, b is 7. Okay, so which satisfies. 6 over 7 plus 2 over b is 1. Let's see, this b is 14. Also workable. Okay, so the only 2, which is 2 cases, which is when a is 5, b is 7, and when a is 6, b is 14. 2 cases, the answer is E.
That's everything for today's lesson. Please click like if you like this video and subscribe my channel. Thank you.